Hey folks, welcome to the second video. So in the last video we have seen why do we need to learn about system design, okay? So in this lecture, like I told in the last lecture that we will first go to one node and slowly we will scale up to multi nodes, okay? So our topic will be how can we create database, okay? DB. So let me first tell you the difference between DB MS versus DSA. Okay, so what is DSA? DSA is the optimal way how you can store information or data inside RAM. Okay, whereas DBMS is basically how you can store optimally data inside hard disk. Okay, inside hard disk, how you can store it. Okay. When I say optimally, what do I mean? Like how can you read the data as fast as possible? How can you manipulate the data as fast as possible, etc., etc. Okay. Now let us understand how can you store data. Okay, like in general. So let's understand about the first way how you can do it. It's the layman way, very easy. Okay, that is indexing. Okay, so what is indexing? So let's say we have an array. Okay, and we have index of array 0 1 2 3 4 5. Okay, we want to store like id number 1, that is Akash. Okay, id number 2 is Ashish, id number 3 is Bob, things like that. Okay, so what we can do, like we can store here Akash. Okay, we can store here Ashish, we can store here Bob, etc., etc. Okay, what is the problem with this? Okay, so the first thing is what is the problem with this? Okay, cons. Okay, this array is stored in RAM. Okay, RAM. So once the power goes off, your data is gone. Okay, this is the first problem. Second is how can you search any data? Okay, so let's say this is your array. Okay, 0 1 2 3 4, and here is like 1 Akash, 2 Krati, okay, 3 Ashish, anything. Now you want to search Ashish. Okay, search Ashish. How can you search it? You have to go for like 0 is index number 0 equals to Ashish? No. Is the index number 1 equals to Ashish? No. Is index number 3 equals to Ashish? Yes. So index number 3 is Ashish. Then you can give the relevant data whichever is with Ashish, like ID, roll number, whatever. Okay. So the time complexity is O of n. Okay, which is very slow. So if there is like 1000 data or 1000, 2000 data, it's okay. But when there are millions of data, this time complexity is is going to skyrocket. Okay, so this is the second problem. So first one is RAM. Second is slow O of n time complexity. Okay. But what is the pro? Pro is very easy to implement. Okay, so what can we do better? What can we do better than indexing? Okay, the second way is hashing. Okay, so the challenge is, so like we have seen that in indexing all the data is stored inside your RAM. Okay, so here what we will do, we will store every data inside your hard disk. Okay, so let's say this is your hard disk memory, I mean hard disk storage, and your storage is like 0x f1, 0x f2, like this. Okay, blah blah blah. So there will be a black box. Let's say this is hashing function. Okay, This is hashing function. So whenever user insert something, okay, let's say it is trying to insert one Akash, okay, so it will say hashing function, it will create for Akash, the hashing function is, let's say, 2, okay, so it will store Akash here, okay, Akash is stored here. Similarly, it sent like 2 equals to Krati, okay, so it will, let's say Krati's hashing function is this one, here is Krati, okay, so this way we will store everything inside data. Good thing about this is, like, pro is everything is stored inside hard disk, okay, so let's write pro stored inside hard disk, okay, so the data is persistent, okay, but the what is the con is, first, what if two names, let's say Akash and Ashish, okay, let's say both have hashing function, when they go through hashing function, both gets an ID 12, let's say both gets an ID 12. How will this work? Okay, so this is your array again, okay, so hashing function is there. For Akash we got 1, so Akash is here. For Ashish also we got 1, so either Akash will delete and Ashish will replace Akash, or what we can do, Akash is still there, and for Ashish we make it 1 plus 1, so Ashish will be stored here. What if this is also occupied? Then we will do plus 2 plus 3 plus 4, like that, okay. So the problem is, like, there can be collision. This is called hash collision, okay, so there will be hash collision, okay. So the con is, this is the first problem, and the second problem is, hash function can generate random hashing IDs, correct? So how a hard disk is actually made, okay, let's first understand like how a hard disk actually works. This is your hard disk, okay, this is your hard disk, and there is a pin, okay, which reads the data, okay. Now this, each of this, like this thing, strip is called, this strip is called track, okay, this is called TRACK, track, okay. This whole thing, this is called sector, ACCTOR, and one of this block is called block, okay, BLOCK, okay. So when you read a data, you have to read one full block, okay, and this needle just jumps to a block and it reads. And how to identify a block? A block is combination of sector and track, okay. So let's say hashing function, so let's say Akash is here, okay, Kriti is here, okay, Ashish is here, okay, let's say Anushri is here, okay. So this pin have to jump around the whole disk to find the data, okay, and jumping, like the physical jumping is extremely slow, okay. So with hashing, the pro is data is persistent, okay. The con is collision, collision can delete your data, or collision can delete your data, or it can go 1 plus 1 plus 1, which is slow, okay. So O of n time complexity. And the second thing is hard disk, hard disk pin need to be physically jumping, okay, it will physical jump, due to which it is slow, okay. So the hashing function is also slow. Now as we have seen, like in this hard disk, okay, typically each block is of like 500 KB or something, okay, let's say 500 KB, and Akash is only let's say 1 KB, So for reading 1 KB of data, you are reading the whole 500 KB of data. So this is wastage of time, right? So that's why we will not use hashing. And the third solution is using B tree. Okay. We will learn about B tree in this next lecture. Thank you for watching this video. Okay.